This is my 27th lecture on complex analysis for 5th SEM DSC students. I am Ms. Ranjana Dutta from the Department of Mathematics, the Graduate School College for Women. Today we will discuss more examples on bilinear transformation. Show that the transformation W is equal to 2z plus 3 divided by z minus 4 changes the circle x square plus y square minus 4x equal to 0 into a straight line 4x plus 3 is equal to 0, and explain why the curve is not a straight line. So W is given. So from this, find the value of Z. And then Z bar, also find that Z bar. So Z, after calculating Z and Z bar, now the circle, equation of the circle x square plus y square minus 4x equal to 0. In place of x, like that is x plus iy, x minus iy minus 4x is equal to 0. X square plus y square can be written as x plus iy into x minus iy. So after changing them in z, we can write it as z into z bar minus 2z plus z bar is equal to 0. So substituting these values into, we get 4w plus 3 divided by w minus 2 into 4w bar plus 3 divided by w bar minus 3, whatever written, which can be transformed into z, which can be written as W, and we can write it as shown on your screen. So now W is equal to 3z plus 3 divided by z minus 4, and we know W is equal to U plus IV, and U plus IV, 3z in place of z, we split it up as x plus iy plus 3 and so on, and then separating the real parts and the imaginary parts, we can write it as U is equal to, as shown on your screen, and V is written as shown on your screen. Then the Z curve given by x square minus 4z plus y square equal to 0 can be written as U is equal to 3x minus 12 divided by 4x minus plus 16, and ultimately this value is equal to minus 3 by 4. So minus 3 plus 4, this is the curve, this is the equation of a line. Similarly, take another example. W is less than 1, changes into the real axis, into real z less than equal to 0. W is given, and W is given, and W bar is equal to also given. Hence, if W is equal to 1 plus Z divided by 1 minus Z, W to W bar minus 1 can be calculated, and after that it gives 4 real Z divided by mod of Z minus 1 the whole square. Real Z, when here transformed into when real Z is less than or equal to 0. So when real Z is equal to 0, what is the value of W? And when real Z is less than equal to 0, and what is the value of W? So here under this, W square minus 1 is less than equal to 0 if real Z if real Z is less than 0, and after that you can see whatever written here. Next, show that both the transformation W is given and W is another value of W is given. W and W bar. Another value of W is given. So if W is given and W into W bar, we can calculate W into W bar minus 1, and after the calculation we find it as minus 4 real Z 1 plus Z plus 1 the whole square. Now see here, W square minus 1 is equal to minus 4 real Z into 1. When real Z is greater than 0, then W square minus 1 will be less than 0. And if the real Z is less than 0, then W square minus 1 will be greater than 0. Hence, W is representing a circle, and real Z, the right hand side, gives the real part axis or imaginary axis. So W square minus 1 is less than equal to 0 according as real Z is greater than or equal to 0. Hence proved. Again, another example, W is given and another W is given. Then finding W bar, we can find W bar minus 1, and after that we can get the value. Again we get minus 4 imaginary Z divided by Z plus 1 the whole square. Here we have to transform W is less than or equal to 1 to Iz greater than or equal to 0. When Iz is equal to 0, what is the value of W you can find, and when Iz is greater than 0, what is the value of W, and when Iz is less than 0, what is the value of Z. What is the value of W, and then plotting them we can see the transformation. Hence, so student, today this much only. Thank you.